So here, this is chapter 8, and we're actually skipping chapter 7. Now, a part of me is not happy with that, only because chapter 7 does set theory. And set theory, it can be tricky, but it is useful. In fact, they use set theory in this chapter. But we'll be okay, though. But basically here, what we're going to look at is probability. And probability, it's really, you'll see what it is, but it's really just a way of determining how likely something is to occur. How likely is it when you roll a fair six-sided die? How likely is it you're gonna roll a 2, or how likely is it you're gonna roll a 3? Well, like even saying it's a fair-sided die, what does that mean? Probability deals with those kinds of questions. It's actually it's a subject area of mathematics. It's pretty interesting. That's what we're going to look at, and we're going to see some basic concepts associated with probability. Again, the notes were emailed, just letting you know. We'll see different concepts associated with probability. Then we'll see this notion of complementary events. I mean, event you'll see is actually, well, you'll see what I mean. I don't want to say too much now. We will see something similar called odds. Namely, it's going to be the odds in favor of and the odds against something. I know, for instance, they use that in casinos, at gambling places. It's not quite the same thing as probability. However, it is related. And this is an expected value. That's where I got up to with the other class. With expected value, the idea is basically if you're how do I say this? You're playing, I guess, a game or something where you could win or lose money. Expected value is how much you expect to win or lose if you keep playing the game over and over and over again in the long run. I mean, that's probably not going to make much sense now, but when we get to it, I hope it does. But that's the idea with expected value. You'll see, well, we'll go more into that later, though. This will come up later on when we do the odds, basically stuff with fractions. We will work with fractions a bit in this class, in this, chapter. And this is just something I felt better pointing out. If you have 3 numbers, let's say, x, y, and z, we're assuming that y and z are not 0, as you can see here. Okay, we're assuming that right here, as you can see. Then, okay, what happens is this. Basically, what happens here is you have one fraction, you have a big fraction, and in the numerator and denominator themselves, you have fractions as well. And essentially what this is saying is these denominators, y, you can actually cancel and be left with this. So in the fractions in top and bottom, the denominators actually cancel. I mean, it's really not hard to see why, I hope. It's really just basic algebra. This will come up a bit when you work with odds. You'll actually deal with fractions like this. I mean, I hope it's making sense what I'm saying. So again, it's just basically you can multiply top and bottom of this big fraction by y, and then the y's will cancel. So hopefully that makes hopefully that makes sense. But we'll see. Okay, so now the question is, what exactly is probability? Well, as I said already, the probability of a specified event is just how likely that event will occur. It's a way of specifying that, how likely the event will occur. And there's actually different viewpoints one could take. I don't remember if I said it last time, but I might have. With a subjective viewpoint, there you're basically making an educated guess but you're not able to perform the experiment for whatever reason. For instance, I think the book does this with sports. They do it with hockey. They do it, I think, with baseball or football. But I mean, if you think about, let's say, basketball, although I guess with any sport, you might ask, how likely is it that the Chicago Bulls win their next game? I don't follow sports, so bear with me. How likely is it that they'll win their next game against, a different team? Well, that kind of experiment might be hard to, to form. Perform, that's it, to perform. I mean, mostly because you would need to know who's playing that day, the exact conditions the players will be in. You might have to know the temperature of wherever they're playing, where they're playing, stuff like that. That's not always easy to determine, if it's even possible. So generally, people will make a subjective guess an educated guess on that. Another viewpoint that's more practical and more approachable today with technology is experimental. There, you do the experiment over and over and over, and you get probability from that. So if you want to know the probability of, let's say, rolling a die and rolling 2, so you want the probability of rolling a 2 on a fair-sided die. Well, for that, you could just keep on doing the experiment, 100 times, 1,000 times, maybe more. And you just mark down how often 2 occurs, I guess. That's more possible today because we have computer simulations. In other words, we have advanced technology that can help us with that. What we're going to do, though, is we're going to consider the theoretical approach, the theoretical viewpoint. Basically, that's where we're going to do calculations and use theory. Hence the name. So that's what we're going to do here. So first, we need some terminology. I mean, really, math is just like any other science in the sense that there's always some terminology and important vocabulary there. This is no different. Probability, you have experiments. An experiment is just a controlled operation that will yield a set of results. So let me say it again. It's a controlled operation that yields a set of results. Like rolling a die, let's say, or flipping a coin. Or later we'll see choosing a card at random from a standard deck of playing cards. And when you do an experiment, there's going to be results that you can get. Like when you're rolling a die, you may roll a 1, a 2, or 3, or so on. Those are what we call outcomes. So outcomes are the results you can get from an experiment. Now, from experiments, you can have events. An event, by definition, is a sub-collection of the outcomes of an experiment. It's just a sub-collection. I mean, really, it's a subset, but it's just a collection of outcomes from the event. So it's a group of outcomes. It's either a single outcome or a collection of outcomes. So like rolling a die, let's say, if we go back to that, rolling a 2 would be an event. Rolling an even number, so in that case, rolling 2, 4, or 6, that would be an event. So that's what an event is. Now, a simple event, that's an event that you cannot break down any further. For instance, if you roll a 2 when rolling a die, that's an event you can't break down any further. How can you roll a 2, right? You just roll a 2. There's no easier way to get it, so to say. It's not like with rolling an even number. That event you can break down. You can get that event by rolling a 2, 4, or 6. Or rolling a number less than 3. You can roll a 1 or a 2, so that could be broken down. And then we have the sample space. That's just a collection or a set. Set, you could think of set as a fancy word for collection. The sample space is just a collection of all possible outcomes. That's all. I mean, when we do some examples, I think it will make more sense. Before we do some, let me just stop the recording.